Hey everybody, welcome back to our second video for Notes 8, where we are continuing the conversation of adding and subtracting fractions. Now, in our last video, we went through the adding and subtracting. Remember, we had to have a common denominator. Well, over the last two lessons, there's been a couple of times that I've mentioned improper fractions. An improper fraction is any time that the numerator, the top of our fraction, is greater or bigger than the denominator, the bottom. So things like 3/2 or -4/3. An improper fraction happens anytime I have more than a whole value. So for example, 3/2. 3/2 physically means I have 1/2, 2/2, and one more halves. 3/2 physically means I have 3 halves of like a circle, for example. Well, this is considered improper because I have more than one. The correct or proper way to write it would be as a mixed number. Mixed numbers is where I say, hey, these two halves right here really make one whole circle. And then I have a half, 1/2 more. So in this lesson, we're going to practice going back and forth between improper fractions and mixed numbers, or from mixed numbers to the improper fraction. So first, it says write the mixed number as an improper fraction. I'm going to go through this one time the long way, then I'm going to show you the shortcut. So this example physically means I have 1, 2, 3, 4, 5, 6 circles, and then a quarter more. Now, if I'm going to write this as an improper fraction, what I have to do is use the denominator. Oh, come on, computer. I need to use that denominator to break my wholes, right, my whole numbers into parts. Notice that when I do that, when I take my 6 circles and I break them into 4 parts each, that creates 6 circles times 4 parts, 24 parts of the circle. Plus, I had one more, so in all, I have 25 parts of the circle, each of them being 1/4 in size. So what we're basically doing is using that denominator to break my circles into parts, which if you notice, there's a shortcut to this. If I multiply my 6 wholes times 4 parts each, that gives me the 24 parts from my circles, and then I add in my 1 extra for 25 parts. I keep that denominator to tell me what size parts I had. That denominator still has to stay common. So let's use the shortcut again on the next one. This has no impact on a positive or negative, so this should still stay negative. The first thing I'm going to do is take my 4 wholes, my 4 whole numbers, and multiply it by my 3 parts each, which gives me 12. But I had these 2 extra parts here that I need to add in. So when I add the 2 extra parts, I end up with 14 parts, or 14 thirds. There will be a few problems on your test or on maybe a final exam where I ask you to to transition, right? To translate this from mixed to improper, improper to mixed. However, on these, like for number 8, the one we did in our previous video, that was technically improper. I will accept it in this form, or if you go through our next process where you find out that this is 2 1/60. I would accept either of those answers unless it specifically says write the mixed number or write the improper fraction. We can also go the other way. If we already have the improper fraction, in order to create the mixed number, I need to divide my values. If you remember back in our lesson, I think it was lesson 2, where we were dividing our whole numbers, there were times that we would divide and get a remainder. Well, guess what? That remainder was basically telling us those extra or leftover parts. Like if I was to divide 25 by 4, I would end up with 6 as a whole number, and I would have a remainder of 1, telling me there was one part left over. So if I'm going to divide, remember the top number goes inside the house, and I'm dividing this into 4 parts. So 4 goes into 13 3 times, which uses up 12 out of my 13 parts. 12 minus 13 is 1. There's nothing left to bring down, so this is my remainder. Well, now that we've talked about fractions, what this is telling me is that I went in there 3 whole times and had 1, remember what I divided by, 1/4 left over. Let's try that again. Number 12, I have negative 47 divided by 5. My rules say I should end up still with a negative result. But in order to change this into that mixed number, I need to take 47, the top, and divide it into groups of 5. Remember, each 5 parts will make one whole circle. Well, 5 goes into 47. Ooh, maybe we're not too sure. So look on your 5 list. And remember, I can go all the way up to it, but not past. 45 is as big as I can go without going over my 47 that I have. So that means 5 can go into 47 9 times. And that will use up 45 of my parts, leaving me with 2 left over as my remainder. So in the division process, I went in 9 whole times. I made 9 whole groups and had 2 out of the 5 left over. Next up, use what we know about mixed numbers and fractions. So we're subtracting and we're going to divide to answer in the simplest form. Friends, there are a couple of ways you can do this. I could break this up and do 4 minus 3 and then 2/3 minus half, but sometimes that's going to create a problem. So instead, let's change to our improper fraction first, and then we'll actually subtract. So remember, the shortcut way says I need 4 whole groups of 3 each, which gives me 12. Plus I had 2 more parts, so I had 14 parts in all. 14 parts in 3 pieces. Do not leave out that denominator. I had 14 pieces of a third, so I've got to keep that fraction line. And I'm going to subtract that by 3 times 2 parts. 3 wholes, 2 parts each. Multiply those together. Add in your extra. I have 7 halves. Now remember, if I'm adding or subtracting, I have to have a common denominator. So my least common multiple says my groups of 3, 3, 6. Groups of 2, 2, 4, 6. So my common denominator for both of these is 6. Now in that process, my 3, I needed 2 groups of 3, so I need to multiply by 2. 2 times 3 gives me 6. Top and bottom, 14 times 2 is 28. In my 2 list, it took 3 groups to get to that common denominator, so I'm multiplying by 3, top and bottom. Common denominator stays common. 28 minus 21 is 7. And this is improper. While typically I would accept this, note it says change into a mixed number. So if I'm going to convert this, remember that means I divide top number divided by bottom number. 6 can go in 1 time, using up 6 pieces in the process with 1 remainder. So that tells me if I have 7 pieces, I can make 1 whole group and have 1 out of 6 left over. All right, one more. These are those same 2 fractions, so I still have 14 thirds, but now I'm dividing by 7 halves. Remember the division process, I don't need anything to be in common anymore. This was from our last lesson where we had to keep, change, and flip my fraction. So keep the 14 thirds, multiply, right, change that sign to multiplication, and flip to 2/7. This is also where I was able to think about having to reduce. I cannot reduce in addition subtraction until I'm in the end, because my main focus in addition subtraction is that common denominator. However, multiplication, division, by all means you can reduce. Keep in mind what I'm doing here. I've got a 14 times 2 across the top. I'm actually going to flip that order because I can multiply in any order I want to. And across the bottom, I have a 3 times 7. I flipped because I was kind of planning ahead here. I remembered that 7 and 14 have something in common. 7 and 14 both show up in the 7 list. That means I can divide a 7 out of both of them to simplify my life. So I still have a 2 on top, but when I do 14 divided by 7, I have 2 with it. On bottom, I still have the 3. I'm not changing that one. But 7 divided by 7 was 1. So I have 2 times 2 is 4. 3 times 1 is 3. Now let's see if we can do this without having to go through the process. If I'm going to divide, I can divide 4 divided by 3 one time and have 1 left over. Y'all, if you're struggling with this concept, I have 4 parts. I use 3 of them to make a group, and I have 1 left over. Still of that 1/3 size. All right, friends, last problem here. You're baking cakes for your friends. The recipe calls for 2 1/3 cup of sugar per cake. If you have 15 cups of sugar in total. My total is 15 cups. Then how many cakes will you be able to make? Y'all, if I have a total of 15, I can't magically create more sugar. However, I can divide that by 2/3 so that I can break it up and decide how many cakes I can make. So 15 divided by 2 1/3. First, let's take care of translating or converting that mixed number into an improper fraction. 2 times 3 is 6. If I add that top one to it, there's 7 parts, meaning I have 7/3 in all. Remember, any whole number I can put over 1, change division to multiplication, and flip to 3/7. Now, I have a 15 times 3 on top. I have a 1 times 7 on bottom. What I'm checking is to see if 3 and 7 can show up in that same row, that same list, or 15 and 7. I'm sorry. No, I said that right. 15 and 7. Notice the only time 3, 7, or 15 show up in the same list is in my ones. What that means is I cannot reduce. I have 15 times 3 is 45 out of 7. Now, typically I'd say, hey, stop right there. The problem is, how many cakes is that? In order to find out how many whole cakes I can make, we need to change this into that mixed number. So 45 divided by 7, I can go in 6 times, because 6 times 7 is 42 with 3 left over. So I can make 6 whole cakes and have 3/7 left. I can make 6 cakes. All right, friends, this wraps up fractions. Be on the lookout for something different coming next.